Okay, hi and good evening, student. How are you guys?
Good.
Fine,
Very
fine.
good.
Okay, so before we start, I need you to make sure that you are ready with your pen, books, and calculator. Okay, so let's start our class today. So today we are going to continue with application of differentiation. So at the end of the lesson, we are going to know how to determine the stationary point, extremum point, and point of inflection. Okay, let's start with answering some question from previous class. So if you cannot open your mic, I need you to write your answer in the chat box. So are you ready?
Ready.
Yes.
Okay. So the first question is the graph is concave upward or concave downward?
Upward.
Upward.
Upward. Okay. So let's review the answer. The answer is correct. The graph is concave upward. So how do you know
Okay.
it concave upward?
Smile.
Anyone?
The shape.
Yes, correct. So because the shape of the graph is smiling. Okay, here's one tip for you. You can see the letter U right in the concave upward. So you can remember the shape of the graph by seeing the U. Okay, the second question is the graph is concave upward or concave downward? I hope no one confused about this already.
Downward.
Downward.
Downward. Okay. All of you answer it correctly. It is concave downward because the shape of the graph is Z. Okay. So let's proceed. I want to ask you, what happened at stationary point? Anyone know the answer?
Don't don't know. Pen.
Don't know?
Don't know.
Stationary.
Okay. So at stationary point, dy dx equal to 0. But what does dy dx mean in a graph? So if we find the graph, if we find dy dx of a graph, what does it mean?
Slope.
Yes,
Gradient.
correct. Okay, so it's a gradient. We can also call it slope too. Okay, so next. So stationary point, there are three main points, which is maximum point, minimum point, and inflection point. A stationary point is known as a turning point if the point is maximum or minimum point. So extremum point also can be called turning point. Okay, so let's proceed with extremum point. Can I ask someone to volunteer to read the definition?
I can.
Okay, please Iza.
Okay, extremum point, maximum and minimum are point where a function reach a highest or lowest value respectively.
Okay, so from the definition, maximum and minimum means it reached the highest or lowest. So in this case, the maximum point at the highest value. So for this point, it's a minimum point because it at the lowest value. Okay. Now let's proceed with step to find extremum point. Can I ask any volunteer to read all the steps?
City.
Okay, please read.
Steps to find extremum points. Number 1, rewrite the given information such as y. Number 2, find dy over dx. Number 3, find x when dy over dx equals to 0. Number 4, find derivative dy square over dx square. Number 5, substitute x into dy over dx square.
Okay, good job, Hanis. Okay, dy dx also can be called as first derivative. And for this one, we can also call it as a second derivative.
Derivative.
Yes. Okay, so let's proceed with inflection point. So, can I ask someone to volunteer to read?
Me.
Okay, please read, Anis.
Inflection point. A point of inflection is found where the graph of a function changes concavity.
Okay, so it means you can see the diagram. The graph is changed from concave up to concave down, and then it's changed again to concave up. So, the point in the middle is the inflection point. So, in this graph, it has two, which is x1 and x2. Okay, next step to find inflection point. So, this we will go through during the example. Okay, now I will proceed with the nature of stationary point. There are three nature of stationary point. The first one is if the sign of dy dx change from positive to negative, then point S here is the maximum point.
Maximum point.
So if for the second nature, if the sign dx dy change from negative to positive, the point here is
Minimum point.
Minimum.
Minimum.
okay, good. Okay, so the third nature, if the sign of dy dx does not change, which means this one is positive and this one is still positive. It means point S here is
Inflection
Point.
point.
Inflection point.
okay, good. Okay, now let's see the graph for more understanding. Okay, class, I want all of you to observe the graph. I will give 30 seconds for you to do so. Okay, why does the graph have two different color? And what does it mean by blue color and red color? Anyone know the answer?
Red color increasing.
Increasing.
Okay,
Blue
Blue
decrease.
Blue
color?
color decreasing.
Okay, correct. Okay, so based on the diagram, the red is referring to increasing point, increasing function graph, which means it has the positive gradient. Okay, it means when we say gradient, dy dx is greater than 0. Okay. For the blue line, it means decreasing. So blue is referring to decreasing function graph, which means it has negative gradient. So it means dy dx is
Less than 0.
Kecil zero.
okay, betul. Okay, correct. Can you follow me?
Yes.
Yes.
Okay.
Yes.
Okay. So as you can see in the graph, there are 3 points. So point A, point B, and point C. So all these points have dy dx equal to 0. Okay. What does it mean? It means point A, B, and C are stationary point of this function. Okay, now I want all of you to find out what is the nature of the point. Okay, I'll repeat randomly 3% to share their answer. So are you done or do you need some more time?
Done.
Okay.
Done.
So for point A, can I have Isaac?
For B
For A,
maximum point.
maximum point. Okay. For B, can I have Amira?
Minimum.
Okay. So For point C, can I have Awatif? Awatif ada tak? Okay, never mind. Anyone want to answer?
Can I try, teacher?
Okay, please.
Inflection, points of
Okay.
inflection.
So, let's check the answer. Okay, all of you answered it correctly. Okay, thank you. Okay, now let's do the example for further understanding. Okay, so example 1. Given the curve y equal to x power of 3 minus 3x plus 2. Find the coordinates of the turning point of the curve and determine the nature of each stationary point, and B, the inflection point of the curve. So this question have two things to find. For A, we need to find the turning point and stationary point. So turning point is what? What is under turning point?
Maximum.
Maximum, minimum.
And minimum. So let's start the example. Okay. So the first step, we need to rewrite the given information. So let's do this together, okay? Y
Okay.
is equal to
X cube
X
B
minus 3x.
3x plus 2.
Plus 2.
okay. So next we need to find the first derivative. So dy dx equals to
3x
3x
square minus
minus
3.
3x squared minus 3. Okay. So let's proceed with the next step. Okay. We need to find dy dx equal to 0. So just now, this is what we found. So 3x squared minus 3 equal to 0. So first, we bring this to the right side. So 3x squared equal to 3. Then, we divide both sides with 3. We get x squared equal to
1.
1. Okay. So, x is equal to
1.
Plus minus 1.
positive. Okay. So, next we need to step 4, substitute values of x into y. So, we get this value just now. We got two value. So, let's do one by one. So, when x equal to 1, y equal to plus 2. Okay, can you help me by pressing the calculator?
0.
0.
0. Okay, thank you. Okay, for the next one, when x is equal to negative 1, y is equal to negative 1 minus 3 plus 2. So, we got
Negative 2.
negative 2. Negative 2 or 4?
I vote for.
Okay,
4.
4. Okay. So, from here, we already find the stationary point. We already find the turning point. So, the first one is 1, 0, and the second one is negative 1, 4. But we still do not know the nature of each stationary point. So let's proceed. For the step 5, we need to find second derivative. So can someone help me? We get
6x.
6x. Okay. So for next step, we need to substitute the x into the second derivative. So our x is 1
1
and
and
negative.
negative 1.
So when x equal to 1, we got second derivative.
6.
Okay.
6.
When x equal to -1,
-6.
Negative
okay.
6.
Okay, so from here, we need to know, is 6 greater than 0 or less than 0?
More.
Greater than zero.
Greater than
Greater than
Greater than
0.
0.
Okay, how about -6?
less
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 than
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 0.
0.
Okay, so from here, we can conclude that from the coordinate that we found before, 1, 0 is the minimum point and -1, 4 is the maximum
Maximum point.
point. Okay. So for step 7, okay, we already solved the question A. Now we are going to solve the question B. So we need to find x when second derivative equal to 0. So let's do this together. So 6x equal to 0, we got x is
0.
0. Okay, now we are already at the last step. So we need to substitute x that we get just now into the y. So when x equal to 0, y equal to,
0.
are you sure?
No, wrong. Wrong, Akila.
Oh. Oh.
Drop, drop, drop.
2.
Okay, the answer is 2. So here we can find that inflection point is 0, 2. Okay, here is the complete working. You can copy it on your books. Okay, now let's compare our answer with the GeoGebra. So we got minimum point 1, 0, and GeoGebra also got 1, 0 over here. Can you see?
Yes, teacher.
Okay,
Yes.
so we got maximum point -1, 4. We got the same answer. And last, we got inflection point 0, 2. GeoGebra also got 0, 2. Okay, so now I will, okay, so we did it the question. Okay, now
Yay.
I will conclude the stationary point. So stationary point, there are three main, the important part, which is maximum point, minimum point, and point of inflection. So for maximum point, the first derivative is equal to 0, and the second derivative is less than 0. While minimum point, the first derivative equal to 0, and the second derivative is greater than 0. While the point of inflection, both of them, first derivative and second derivative, are equal to 0. So we already came to the end of this class. Here I provide some question for you as a homework.
Oh
Excuse me, Teacher Farah.
no.
You have
Okay.
another 2 minutes
Too
left.
many,
Okay, thank
teacher.
you. No, it's just a little. One page only.
Okay.
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 So please try to do it by your own. And I will collect this homework next class. So thank you for your cooperation. Till we meet again. Thank you.
Thank you, Teacher
Thank you,
Farah.
Teacher
Teacher.
Thank you,
Farah.
teacher.
Thank you, Teacher Farah.